Okay, we're going to try again. I'm going to try and write bigger, make it clearer, so you can actually see it. I am getting a electronic whiteboard, which I'll do on my computer once I get it all set up, but just for those students that have got exams coming up, I thought I'd just do this very quickly. If you remember from the last one, let's just have a look at this beautiful unit circle. Now, as I said before, you guys need to be so familiar with this because it tells you so much. So if we go back to 0, 90, and remember, if you put pi over 2, pi, 3 pi over 2, and 2 pi. And remembering that as we go around, we have a look at our vertically opposite, or our x rule. That is equal to that, is equal to that, is equal to that. And that's very, very, very important to remember. If we go this way, it's not this angle we're measuring, but this angle. And this one going this way is always 180 minus theta, or pi minus theta. Now I hope you can see that. I hope I'm writing big enough. This way is this angle, not this angle, so it is 180 plus theta, or pi plus theta. Always use both of them. Get into the habit because you get better and better and better working at it. I always do it in degrees and then convert it unless it's easier to use your fractions. Here it's 270. If you have a look here, we don't do anything this one or anything here. It's this angle here, which we go that way, which is 360 minus theta, or 2 pi minus theta. Here is 0 plus theta. Now that's for when we go this way, and remembering this way is from 0 to 2 pi, and we go anti-clockwise. When we do the minus theta, we go this way, and that's a whole different story. But keep those in mind. That's 0 plus theta, 180 minus theta, because we're getting closer to 90, or closer to 0. Here, we're going closer to 360, so we're adding theta. Now these all, we remember, was all students take chemistry. Now I like to use this when we're doing the sine, cos, and even the tan graphs. So if we have a look, if it was the unit circle, if it was that unit circle, this would be 1, and this here would be 1, because it's just the radius of the circle. Always remember here, this here is 1, 1, and then we can work this one here out. Now, if we have a look, we know the trig ratios are sine theta is O over H, cos theta is A over H, and tan theta is O over A. Now we know that from year 8 onwards, or 9 onwards, one of those. Soccer 2 up. If we have a look at our unit circle, with Pythagoras, that's your H, or not your Pythagoras, sorry, with your trig ratios. If that's your theta, that's your opposite, and then you always draw the adjacent last because he's next to you. It's like sitting across a table is opposite. The hypotenuse is always opposite the right angle. And I always label those. Now if we have a look, we go that one step a little further. This value here is your y value. This value down here, which is your adjacent, is your x value. Keep that in mind. So sine is opposite, which is your y value, and your hypotenuse is 1. So it's just y. Now you probably already know this. This is the theory behind it. I always feel like you need to know the theory to understand it, to memorize it, to replicate it. Here, the adjacent is your x value over the hypotenuse. And if we look at tan, we can still go from there, but it's a very interesting one. Opposite is y over x. Now that is sine theta over cos theta. And we all know tan is sine theta over cos theta. So then, once we know that and that comes in with a lot of the physics and vectors. We use this as well. So keep that in mind, understand it. If we have a look here, I love doing this one because it is sine of 0, cos of 0, tan of 0. Now 0 is here. If we have a look at here, we know that's 1 unit. If we're looking at the Cartesian plane, your y and your x, this here at 0 is 1, 0. It's here. The angle is 0, it is just there. I love to write, and one of my beautiful things to do is you label every variable you can. And I'll show you my secret weapon for any maths, physics and chemistry problems if you follow the rules. So here we know that it's just the y value, and in this one at 0, it's 0. For cos, it's the x value, which is 1, and then tan is y over x, which is 0 over 1, which is 0. And again, this is very important, something you can use for some of your justifications in some of the harder problems. If we have 0 divided by 1, that's okay, it's just 0. Now this can be then transcribed into our sine, cos and tan graph. I'm only going to do it to 2 pi. And again, just get really, really comfortable with drawing these. And remembering when we're doing the normal sine and cos graph, I love to draw, because when we start doing transformations, we need to know the normal one, which is from 1 to minus 1. And there it is there, from 1 to minus 1. That is how we work it out. Now, if we look at this, for 0, sine is 0. We'll do them in different colours. Cos is 1, and tan is 0, which is a special one. We'll come back to him later. Let's put a little dot there. So that's 0. Let's go to 90. Now again, you may all remember this, and that's great, but we're going to go through it again anyway. 90, if you think of 90, up here, what's the values? The y value is 1, the x value is 0. So at 90, I've got 0, 1. Now, for 90, sine is the y value, which is 1. Let's put him up here. That was in red. He was up here. The cos of 90, and you're sort of getting the little drift here, is the x value, and the x is 0. So cos is 0. And tan, now this is a very, 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 very important one. Tan of 90 is y over x. Now watch this, 1 over 0. And if you put that on the calculator, if you put 0, 1 on your calculator, you'll get 0. If you put 1, 0 on the calculator, it becomes undefined. And we call that an asymptote. And if you know your hyperbolics, 1 over x that has asymptotes, it doesn't ever hit 0 because you cannot divide by 0, it's undefined. And for that, we put in an asymptote. It will get close to it, but it will never get there. Then we have a look at sine of 180. Now again, 180 is here. So what have we got on our unit circle? It is minus 1, 0. So let's just write that here, minus 1, 0. So sine of 180 is the y value, which is 0. Nice and easy. So this comes back to 0. And as you see, we're getting a nice curve. Cos of 180. Is the x value, which is now minus 1. It's over this side, and that becomes this one. It goes here, and here, down to here. So you're sort of getting the drift of what these curves are looking like. And then tan of 180 is y over x, 0 over minus 1, which is just 0. So again, we get a 0. And we can have a look at tan from before and after here. When we have a look at it, it's going to go down from here and from here. It sort of looks like this and then this. So this one here will be like that, because there'll be another asymptote on that side, and here it looks like that. But we'll have a look at the tan graph a bit later. And then let's have a look now at sine of 270. Now 270 is here. That's your 1 unit, and here it is minus 1 and 0. So let's put this here. It's 0, minus 1. That's the y value, which is minus 1. And so our sine at there goes down to there. Our cos of 270 is the x value, which is 0. So here becomes 0. He comes back up to here. And then tan of 270 is y over x, which is minus 1 over 0, which again is undefined. And that becomes the next asymptote down here, and then we find that this does this. Okay, and then when we get back to 360, we're back to 0, and so sine becomes 0. Oops, I should do that red. We'll do it in red. And again, that just continues on. X becomes 1. It comes up to there. And this one becomes 0. So that's your sine, cos, and tan when you go around for 0, 90, 180, 270, back to 360. And they're beautiful little graphs, and if you ever get confused, you can just pop it in the calculator and know where it starts from. I hope that helps you with your unit circle and your 0, 90, 180, 270, 360, and drawing the graphs. Remembering cos theta starts at 1, sine theta starts at 0, and tan theta, we have these asymptotes. Hope you enjoyed that. I'll do the next video. Hopefully that reads a bit better. I'll double check it, and I can't wait to do it on my electronic whiteboard. Thank you.